Good morning, everyone. Today I'm going to explain the Boston House price prediction data. Initially, we need to import the libraries from several sections. First of all, import NumPy as NP, import Pandas as PT, and following all the libraries as they all needed for this programming functions. As per the problem description, we need the house price. There are so many strategies for the price predictions. Initially, find the attribute with maximum correlation to the price, split the data into training and testing, choose linear regression model, train model and arrive at M, which means the slope or the weight, and C means intercept or the bias. Based on the equation y is equal to mx plus c, we need to find the whole relationship with the training model and the attributes. And finally, we are predicting the prices from the testing data. From the section 3 itself, we can able to understand that the loading Boston data. By loading the Boston data, initially we need to print the data. From the available print, we can see that there are 506 data points, 14 columns, 13 features are available. Based on these initial primary values, we are going to find the prediction of prices for the Boston houses. Then we are coming up into the feature sections. In the feature section, we can able to tell that the Boston from the basics Boston data, the Boston features and the names can be featured. Then we are getting into the features called nodes. From these things, we can able to tell that the length is 506 and the data type is float of 64 data are available. Through these data, we can able to get into the idea of target, and we are getting into the maximum target value and minimum target value from the available things. Here we can see that 506 rows were available. From these 506 rows, we can able to find the maximum value and minimum value. Here itself we can see the minimum value of the things 50.0, and the maximum value is 50.0 and the minimum value is 5.0. Thus we can able to tell that the values such as most reliable for these prediction systems. Then we are concatenating the features and targets in a single frame by concluding the rows and columns by in a single sections. Thus, we can able tell that 5 not 6 rows and 14 columns are available here. Then we are going to descripting the of database using the describe function of a data frame object. For this, we need to round the decimal points into 2. From the above available data, there are 5 not 6 rows are available. From that, we need to criticize, or from we need to regularize the whole things into minimum, maximum, 50%, 20% values based upon the availabilities, based upon the user friendly relationships. Then we are getting into the data visualization section. For the correlation between every attribute and target, we need to visualize the data. For that, we are using the correlation data called Pearson. By obtaining the absolute value, scores is equal to, we are using the absolute value. If we are using the ABS in the column number 11, we getting the absolute value. Instead of we are using without entering the ABS, means we cannot able to getting the absolute, thereby we can get the point negative values into it. Then we are getting the list in a zip order, and we are sorting the values in the descending order based upon comparing the correlation values and features together. Then we are getting into the plotting the correlation graph. For the plotting of correlation graph, we need to implement the figure size, figure index, and X label, Y label, attributes, everything into it. Then we can able to understand this is the type of correlation with the target. This graph is plotted with the X-axis of attributes and Y-axis of correlation with the target variable. Then we are getting in the normalization of data. From the X, which means we are initiating a term into it. For initially for the term, we are taking L stat. from the x-axis we can see that there are mainly 14 types of values are available here. For that, initially we are taking LSTAT for the normalization of data. For that, instead of that, we can use RM, inters, tags, this or chas, everything we can use. From the for this, we are using LSTAT. Then the y-axis we are using target values. Then we are creating an instance of scalar object. For this type of data, we need to enter some of the values like x and y data. Then we are splitting the data into equal sets. Here for that we are using point 2 value. With the point to indicate splitting 20% of data into training sets. From the our current available data, we are getting into the mean square error. The Boston housing error using the MSE. Initially, we are representing the names called MXCT. For that, we are giving a value to the n is equal to x into size. For that, we are getting into the learning rate, grade M, grade C, and we are returning the values M and C. For that, next of all, we are getting into the initializing the values M, C, X, C, X, T, learning rate, iterations, and error threshold. And finally, we are returning the whole values. For that, we are giving the values in the threshold by giving the initial value of 1.9. Initially they are giving the 0.9, but I am giving is 1.9. Then the learning rate, iterations, and error threshold. If you are giving the value is much more than that of the 0.025, the error will be occur. For that, before they will initiate that error less than the threshold. But if the error is much more than that of the threshold, means if given that e is less than that of threshold, then we can print the error less than threshold and stopping gradient descent. Otherwise, else, if or else, we can say that it will be null will be printed out. At the same case, we need to return all things again and again. Again, we are getting into the plot scatter, X train, Y train. For plotting a graph, we are using a regression curve. We are giving some other color plots into it. Initially, we are giving B called B for the scattered trains of the X and Y trains instead of scattered program. Then we are plotting the X train of the color called AR into it for a calculation predicted value. Here the predicted value can be tell that M into X train plus C. That's the predicted value. Here we see using like this. Then we are plotting the whole things into an iterations. We are plotting a graph versus iteration versus error. Thus we can plot a graph like this. Again, we are initiating the value of predicted value into this. Thus we can find out the mean square error, and we are putting that errors into the head. And finally, we are again based on the predicted value, we are again predicting again plotting a graph based on this. Thus we can reshape the array and revert the normalization. And finally, we are entering the code for the basics and finalizing the prediction of Boston house. Thus we can find the predicted value for the x test and y test. Thank you.